All right, in this video, we're going to talk about topic 2.2, which I should have written a title, and apparently I did not. It is the characteristics of function graphs. The essential question should be, what are some of the attributes of a function and how are they related to the graphs function? And how are they related to the graphs function? And then the I can statements are going to be, I can identify when the function is increasing and decreasing from its graph. So I can identify when the function is increasing and decreasing from its graph. And I apologize, I'm going into the column. I'm using a different piece of software, a different machine to record on today. And then I also have an I can statement that is, I can calculate the average rate of change from a function. Abbreviate a little bit, average rate of change of a function. All right, we're going to do probably about up through about the first half of it, the explore, and then we'll do the second half in the next video. So identifying the attributes of a function from its graph. You can identify several attributes of a function by analyzing its graph. For instance, for the graph shown, you can see that the function's domain is between 0, x such that 0 is less than or equal to x is less than or equal to 11. So we're at 0 to 11. So we can read the domain. The range is y such that it goes from -1 all the way to 1. Use the graph to explore the function's other attributes. So the function has the values of the function on the interval from 1 to 3. So what it's saying is from 1 to 3. The values mean what are the y values. So when you see value, I did not mean to totally cross that out. I meant to underline it. The values means what is the y. So you'll notice all of your y's up here on top of this thing. They're all positive. They're all positive y values. If I was underneath the x-axis, they would be negative. For the values of the function, so again, we're looking at y's, in the interval from 8 to 9. So 8 to 9 would be this part of the graph. And notice all of those values there are below the x-axis, so those ones are negative. Then they're asking us, and I'm going to go ahead and I'm going to erase on my graph here because I'm going to have other stuff to scribble on there. A function is increasing. Okay, this is kind of crazy math notation. If the interval on the interval, if the f of x sub 1 less than f of x sub 2, when x sub 1 is less than x sub 2. So what that basically means is as you read it from left to right, it's going up. Okay, that's what increasing means. From the interval, the graph of the function that is increasing on an interval rises from left to right on the interval. There it is, right there. It says exactly what I explained. Similarly, a function is decreasing on an interval if f of x is sub 1 is greater than f of x sub 2 when x sub 1 is less than x sub 2. So we're decreasing when the graph of the function is decreasing and the interval falls left to right. So either it's rising or it's falling. So, and we always read from left to right. So the given function is increasing or decreasing on the interval from 2 to 4. So from 2 to 4 on the x, we're going from 2 to 4 right there. We are definitely falling, so we are decreasing. Given the function is increasing or decreasing from 4 to 6. So from 4 to 6, I'm definitely rising. So I would be increasing as I go from left to right. For 2 points, x, f of x sub 1, f of x sub 1, and x sub 2, f of x sub 2 on the graph of the function, the average rate of change of the function is the ratio of the change of the function, the values of your y's basically, to the change in the functions of the x values. For a linear function, the rate of change is constant and represents, big deal, represents the slope. So this is actually a big deal. Put this in the left-hand column. Average rate of change is the same as slope. Okay, that's pretty much all of calculus right there. When given the function's average, what is the given function's average rate of change on this? So basically what you have to do is you're going to use your slope formula. You're going to do your y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or in the context of what we've given here, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So let's actually figure that out for this particular graph. So the function's average rate, so I'm doing, I'm going to label it as average rate of change rather than slope because that's what they started us with. Okay, so I want my y values over my x values. So I'm looking at my endpoint 2, first of all. So I'm looking at that value. It's x equals 2, and it's up at 1. So I've got 1 for my y value there. Minus, I need the y value at 0. So at 0, I'm right here, and that would be the point. Out 1, up 0. Nope, that is not the point I want. I'm sorry. Erase that mess. Okay. I want my x value to be 0, not my y value. My x value is 0 right here. So that's the point. Out 0, down 1. So my y value would be minus 1. We know that a double negative is going to go positive. And then we need the x values. So my x values were what were given to us, 2 minus 0. And you always want to go in the same order. It doesn't matter the order, but it's always good to start with the one at the second point, just so you're consistent. So it looks like I've got 1 plus 1, which is 2, over 2 minus 0, which is 2. So our average rate of change on this one is 1.